We're going to look at box problems today, so applications of polynomials with talking about how we can maximize the volume of a box. So understanding that we had already done kind of an exploration about this with where we would cut and how we would cut a box in order to obtain a maximum volume. So when you think about a box, right, and looking something like this, where our objective is to cut out corners of this like two-dimensional like rectangle and cut out corners of a length so that we can fold those corners up and make the height of the box. So in order to do that, we're going to start by labeling the length and width of the actual cardboard, the rectangular piece of cardboard, so we can form a box out of that. Because if you just cut 1 inch in, or 2 inches in, or 4 inches in, like we're trying to find something that will give us the maximum volume here. So we don't know what that height needs to be. That's what we're going to find out. So we're going to start by labeling the length and width of this rectangle. And then we're going to kind of give another illustration here, kind of showing what that would look like. So this length, 36 inches, is not talking about this to that. It's talking about all of this. Okay, so we're going to write an expression for the volume of this box. So we know that volume is length times width times height. So since I don't know what that height is that I cut, so I cut into this by, I'm going to call this X because I don't know how much I need to cut in. So I'm going to call that X, and I'm going to do that around all sides evenly because I need these to be even. If I don't have these, if I cut 1 inch this way and 2 inches this way, my box is going to be lopsided. I'm forming the height of the box. So for instance, and just to kind of make sense of this, if this entire length is 36 inches and I cut 1 inch here and 1 inch here, then we should know that this right here should be 34 inches because out of the 36 inches, I'm taking 1 here, so that would be 35 inches, and 1 from here, and that would be 34 inches. Okay, so, but we're going to write an expression for the volume, and we need to do that to every single one of these corner pieces. So now we have an expression, or now we have our box labeled with the heights that we cut out that we don't know, we're calling X. And we're going to set this up. So this is the bottom of my box. And this side right here is my length of the box. And this is going to be my width right here. So I'm looking right here. This is the bottom of my box. So all of these side pieces right here, this is going to fold up. This is going to fold up. And this is going to fold up. And so is this. They're all going to fold up, and then we're going to make our box that way. So that's going to be our width. So what do I know about my width? Well, I know that this whole length from here to here, I know that that is 36 inches, but I took a piece out on both sides. So I need to subtract that. I need to subtract how much I took off from my entire width. So I took off an X length from this side and from this side. So when I write my width, I'm going to have to subtract both of those X's, so 2 X's, from my total length. And the same thing goes right here. So if I write this out, my length, I started with length, I guess. My length over here from here to here is 24 inches. But I cut out a side length here and a side length here. So I need to deduct that from those. So for instance, if I cut off 4 inches here and 4 inches here, then this part right here, we should be able to determine what that is. That should be 18 inches. How do I know that? Well, because 4 inches were cut out this way and 4 inches were cut out this way. So that means there's 18 inches left. Okay. So, and we got to do the same thing with the width. So 36 minus 2x, because we have 2 of those. And then the heights, well, we're given the heights. They're labeled. That's what we're cutting out is the height. So this whole side, if I fold those up, that would be my height. So now I have an expression for the volume, which is just length times width times height. Now I can plug all of that in, or write all of that down in terms of length times width times height, and I have this cubic polynomial, and we end up getting something that looks like this. So this is kind of showing without those corners in there, so those would fold up. So now we should have something that resembles something kind of like this. So now I want to determine the length, the width, and the height of the box with the maximum volume that the company will deliver. So I don't know what the length, width, or height is, but I do need to find the height of the box. And if I find the height of the box, because that is x, I can plug that in for my length and my width and find my actual dimensions for that. Okay, so in order to do this, to find the height, I'm actually going to find, if we think about what a polynomial looks like, this is going to be a cubic polynomial. That's going to look something like this. And maybe a little bit different. But either way, we're going to have some maximum here that we're trying to find, and it actually should be moving over a little bit, but we're going to use our calculator to find this. So we're going to end up finding that maximum, because that maximum is going to tell us what the height, the maximum height needs to be in order to obtain a maximum volume. So I'm going to go to my calculator, and I'm going to make sure that my window looks like this. So my min is 0, my max is 30, then I have 5, 0, 2,000, and 100. So make yours match mine. And then we're going to go and find the maximum of that. So remember, we hit second trace maximum, and then we find that maximum value. And when we do, we get something that looks like this from our calculator. So what we need to understand from this is that this right here is our height. This number here, our x value. That is our height. This number right here represents our volume. So we have the height and the max volume. So I'm going to go ahead and plug that in. Now to find my length and width, I just need to plug in 4.7 for x, and I get that. And the same thing for width, and I get that. Now, a quick way to check yourself, right? If we were to take all of these, so volume is equal to length times width times height. Well, if I know that my length is 14.6, my width is 26.6, and my height is 4.7, then I should be able to hit enter and do those, and my answer should be something close to this. I did round a little bit. 1,824.3 inches cubed, cubic inches. And so now we should know that this side right here, or this height, is 4.7. So if I cut out 4.7 from both sides, then we should be able to see what that length is. So in other words, and you can kind of just test this to make sure. So if we do 36 minus 4.7 minus 4.7, we should get 26.6 inches for that width, and the same thing for the length when we plug in that for there. Okay, here we have a metal box manufacturing company makes metal boxes to house electronic equipment by cutting squares and rectangles from a 10 by 20 inch piece of metal. So we're given a diagram here, and we're going to write a formula for the volume of the box. So most of this stuff is going to be kind of similar, right? But what we do need to understand is that this is cut a little bit differently. So our side here from here to here, that whole thing is 20 inches. And so it looks like somewhere in the middle right here is where that sheet of metal is being cut from. So this is going to be the bottom of my box. Our width that we have here is the same as before. So we're taking 10 minus the two x's, the cuts from each side that I'm trying to find the height for. And that's always going to be the case. The height will always be x. But the length, on the other hand, is going to be a little bit different because I'm cutting right here. If this whole side is 20, then this from here to here is 10. And notice I'm only counting one of these x's and not both of them, because this side's going to fold up and form over the top. So when I write this, I'm going to take my 10 inches minus the cutout I have for my height. So it's going to be 10 minus x, not 2x. And it's not going to be 20 either. So now we have this volume that looks like this, and we're going to do the same thing. So we're going to plug this into our calculator using this window. And when we do, we should get a max from calculator 2.1 and 96.2. So that 96.2 is my volume. The 2.1 is my height that I need to cut out from. When I plug 2.1 back into my length and my width, I get the following dimensions. So once again, to put this kind of in perspective, this length right here, this should be 7.9, and this width should be 5.8. And then the height that I have in the box should be 2.1. All right, guys, so you have, I believe, one more assignment over this, worksheet 5.6. Make sure you check your solutions. And from what I understand, you do need to make sure you pay attention to the open box one. So definitely before this problem, the one where it was like something minus 2x times something minus 2x times x, make sure you know how to do those.